In number 23, this looks like a factoring problem, so I'm going to try to factor it. So 4 times negative 3 is negative 12. Can I get to negative 5? Okay, so we have the factors of 12 from earlier. So I look to see, can any of these factors make a negative 5? And the answer is no. None of them can. So that means that I have to use the quadratic formula. So I labeled them ABC. And then next, we need the formula. Okay. So, first, after I've labeled it, I need to plug in my numbers. Do this right here. So I would have x equals a negative b. Well, b is already negative here, so it's a negative into a negative. We should know that that will become positive. Then we have the square root of b, which is negative 5 squared, minus 4 times a times c. So a is 4 and c is negative 3. I multiply that at the bottom by 2 times a, and a is 4. So now it's a matter of just simplifying. So this part here we know is going to be a positive 5. 2 negatives make a positive. At the bottom we know that 2 times 4 makes 8. Okay? Now, for under the radical, we have negative 5 squared, which is a negative 5 times negative 5. That is a 25. Then we do negative 4 times 4 is negative 16. And then negative 16 times negative 3, is a positive 48. So now I need to go ahead and add these two numbers. And we would get 5 plus or minus the square root of 73 if I add them over 8. 73 is not a perfect square. It cannot break down. So that is my solution. Lastly, we have 24 and 25 simplifying radicals. So the square root of 64 is 8. And if I wrote 40 x's, I would have 20 pairs. There is no leftovers here, so I just leave it 8x to the 20th. In number 25, the square root of 9 is 3. But 12 is not a perfect square, so we can break it down. I'm going to use 3 and 4. So we have a 2, and a 3, and the 2 goes outside the radical, and the leftover 3 goes inside. This cannot reduce. This isn't a radical, this is not, these do not cancel. So I would just leave it 2 radical 3 over 3. And that is my final solution.